Hi everybody, this is Dr. Hamid. Today we are going to start chapter 5, which is about number theory and real number system. Okay, uh, we are starting with section 5.1 today. Okay, and in this lecture we will start by introducing the subject of number theory, which is basically about the study of numbers. And we will talk about different classifications of numbers. We will also talk about divisibility and factorization of numbers, and how to find greatest common divisors, least common multipliers, and we will also talk about some applications involving number theory. Okay, so let's start with number theory. This is the branch of mathematics, okay, which deals with the study of natural numbers, which are also known as counting numbers. Okay, natural numbers are most common ones. Okay, and we use these numbers to count things, objects in our daily lives. Okay, that's why we also call them counting numbers. The set of natural numbers is given by a capital letter N, okay, like this one here, which is bold, and the numbers start at 1, 2, 3, 4, all the whole numbers all the way to infinity. Okay, so these dots at the end should be 3 dots here. These 3 dots at the end means the set goes all the way to infinity there. Okay, now moving on to the concept of factors. Okay, natural numbers that are multiplied together are called factors of the resulting number. For example, when we multiply 2 and 3, it gives us 6 there. Okay, now 2 and 3 are called factors of 6 there. Okay, now, now to explain the concept of factorization, let's look at one example here. Okay, suppose we want to divide 24 women into teams. Okay, now this can be done in different ways here. Okay, let's explore all these different methods here. Suppose we suppose we make one team, and all the people, all the women in that team. Okay, so what will that mean in mathematics? It will mean 1 times 24. It means that we have one team, one formation, and there are 24 members in this. Okay, so since 1 times 24 is 24, that means 1 and 24 are factors of 24. Okay, now this is not the only option. We can also make two teams. Okay, now if we make two teams of 24, then we have to have 12 women in each team. That will mean 2 times 12 equals 24. Okay, so which means two teams and 12 members in each team. Okay, and they result in 24. Now according to the previous slide, 2 and 12 are also factors of 24. Similarly, we can also have three teams, but if we have three teams, then we will have to have 8 members per team. So 3 and 8 also members of are also factors of 24. Okay, we can also have 4, okay, team with 6 women. We can also have 6 teams with 4 women. We can also have 8 teams with 3 women. Okay, and we can also have 2 teams with 12 women. We can have 12 teams with 2 women in each one of them. Okay, similarly, we can have 24 teams with 1 person in each team. So these are all possibilities. Okay, now what you need to remember here is, okay, we all these numbers 1, 2, 3, 4, 6, 8, 12 and 24, they all are factors of 24. Okay, so since again going back to the previous slide, natural numbers multiplied together resulting in a product of 24 are called factors of 24. Okay, or in other words, all these numbers, they divide 24. Okay, we cannot have 5 teams because 5 does not divide 24. We cannot have 7 teams because 7 does not divide evenly 24. So only those are factors which divide 24 with the remainder 0. So now, okay, always keep in mind, any natural number, any given natural number, we can express this as a product of 2, at least 2, or we can have or more natural numbers. We will talk about it in a minute. Okay, let's look at divisibility here. Okay, now a natural number, okay, is called divisible if after dividing, okay, the remainder is 0. Okay, you do not get any remainder, that means the number, it's divisible. If we get any remainder, then it's a different story. Okay, a natural number is called divisible if by any other number if the operation of dividing the first by the second leaves a remainder of 0 here. Okay, now if we talk about two numbers a and b, it is same as saying, okay, that b is a divisor of a. Okay, and we write it as b and this vertical line a here. In terms of an example, for example, look at this one. If we have 12 and this vertical line 24, it means 12 divides 24, or 24 is divided by 12, and it leaves a remainder of 0. Okay, so 24 is divisible by 12 there. Okay, now let's move on to finding factors here. Let's look at one example, okay, where our goal is to find factors, and we are trying to find factors of 24 and 13 here. Okay, remember that when we talk about factors, we are looking for all those numbers which divide 24, and we are looking for all those numbers which are dividing 13. Okay, so let's look at one by one. If we look at 24 here, to find factors of 24, what we do is start by 24 and start dividing it by 1, 2, 3, 4, 5, 6, and so on. Okay, what are we looking for? We are paying attention to the remainder here. Okay, if the remainder is 0, that is the number we want to keep. Okay, so if you divide 24 by 5, you will not get remainder 0, so we don't want to ignore it. But if you we will ignore it. Okay, we will not count that in. So all those numbers which give remainder 0, okay, are factors of 24. Okay, or in other words, whatever divides 24 completely, that will be a factor. So the factors of 24 are 1, 2, 3, 4, 6, 8, 12, and 24. These are all factors of 24. Similarly, if you look at 13, nothing divides 13. Okay, so only 1 and 13 divides it. So these are only two factors here. Okay, so now before I move on, the numbers we were dealing here, they are small numbers. Okay, well, so it's easy to check what divides it, if it is divisible or not. Now if I give you a 5-digit number, a big number, it will be a challenge unless we know some tests or tips. Okay, which number is divisible by what, and so on. So moving on to that, let's look at some divisibility tests. Okay, so this is a summary page, and then I have a bunch of examples. I will go through quickly. So this whole divisibility test thing it is based upon the last digit or the last two. Okay, so just pay attention to that one. For example, okay, any given number will be divisible by 2. Okay, any number, no matter how big the number is. Okay, any number will be divisible by 2 if the last digit of that number is even. Okay, no matter how big the number is, just pick the last digit. If it is even, okay, for example, it is 2, 4, 6, 8, okay, or 0. If it is even or divisible by 2, then the whole number will be divisible by 2. Similarly, any given number will be divisible by 3 if the sum of the digits, all the digits in that number, is divisible by 3 there. Okay, I will show you quick example. Similarly, if the a number will be divisible by 4 if the last two digits, okay, so just focus on the last two digits, if they are divisible by 4, then the whole number will be divisible by 4. Okay, for example, if your number is something something something, and at the end you get 16, you know that 16 is divisible by 4, so that means the whole number is divisible by 4. Okay, similarly 5, a number will be divisible by 5 if the number ends in 0 or 5. Okay, moving on, the number will be divisible by 6 if it is divisible by both 3 and 2. Okay, Number will be divisible by 8 if the last 3 digits of the number is divisible by 8. Okay, the last 3 digits will be easy to check. Similarly, if the number is divisible by 9, if sum of the digits is divisible by 9, number is divisible by 10 if the last digit is 0. Okay, that's given. And the number will be divisible by 12 if if the number is divisible by both 3 and 4. Okay, now the list, this list is not enough, but it still narrows down, it makes our life a lot easier if we just can remember this. Okay, now I'm not gonna go, there. I will leave these, slides in the lecture notes, but I will go through a few of them. Remember, we learned a rule that a number is divisible by 2 if the last digit of the number is even. Okay. Now, suppose this is a big number. Okay, this big number. So, is it divisible by 2? We only need to pay attention at the last. The last one is even. So, this is divisible by 2. Okay. Now, similarly, when the number will be divisible by 3 if the sum of the digits is divisible by 3. So suppose we are looking at this number here. Okay, so add these up. 5 plus 2, plus 3 plus 4 plus 1 is 15. Since 15 is divisible by 3, so the whole number is divisible by 3. Okay, similarly, go through all these slides. Okay, I just tried to give you an example of each one of them so that you feel comfortable there. Okay. Okay. Now, this slide is about, few more definitions about numbers, and we are starting with the most important one here, the prime numbers. Any natural number greater than 1, any natural number greater than 1 that has only itself and 1 as factors is called a prime number. Okay, so prime number will be the one which has only with 2 things which divides it. Okay, it's itself and 1. So examples of prime numbers are 3, 5, 11, 13, so on, so on, so on. Okay, 4 cannot be a prime number because 1 divides it, 4 divides it, and then 2 divides it. So we only want 2 things to divide it, 1 and itself. Okay, so those are prime numbers. Now, next definition is a composite number. Composite number is all those numbers which are not prime. Okay, if a number is not prime, then it is a composite number. Okay, now all the numbers which are not prime, so 4 is not prime, 6 is not prime, 8 is not prime, 9 is not prime, so all these are composite numbers, and this list goes on and on. Okay, now any composite number, okay, we can write it as a product of prime numbers, and this is called prime factorization, a very important concept, I want you to pay attention to this. Okay, when we arrive there, I'll tell you again. So any composite number, we can express this as a product of prime numbers. Okay, now how to do this, how to find these prime factors, there's one method which is called factor tree. Okay, so we know that every composite number can be factored into prime numbers here, and the method used to find those prime factorization is called a factor tree here. Okay, there's a theorem, it's called fundamental theorem of arithmetics, and it says that it guarantees that every composite number can be expressed as a product of prime numbers in one and only one way. You don't have to worry about the order of the factors, with the way we write it and all that. Okay, and one method which we use to find prime factorization is called a factor tree. I'm going to explain that in a minute. Okay, now let's look at factorization. Okay, I'm going to explain this factor tree method by one example here. Okay, let's look at one example of finding prime factors using a factor tree. Suppose we want to find the prime factorization of 700 here. Okay, now to find prime factorization or prime factors of this one, we will start with two numbers. Okay, two numbers whose product is 700. Okay, such as 7 and 100. You can have a lot of other two numbers as well whose product will be 700, but your goal should be to have one as prime. So if we pick 7 and 100, 7 is prime here, so we don't have to worry for simplifying it further. Okay, so we will only continue with one branch. So as I said, start with two easy factors. Okay, two easy factors. Now in this case, let's start with 7 and 100. Okay, so 7, the two product factors are 7 and 100, and 7 is our prime factor. This cannot be further simplified. There are no further factorization here, but we will focus on this one here. Now let's factor 100 into 2. Okay, so we will find two numbers whose product is 100. Okay, and one of them preferably be a prime number. So how about 2 and 50? Okay, again, the reason for that is we want to keep one prime is so that we don't have to worry about this branch. This is done. Only worry about this branch here. Okay, next we can have 2 times 25. Okay, next we can have 5 times 5 there. Okay, and we will end until the end of each branch contains a prime number, and it does. Look at that, look at that. All of that is, every branch ends in a prime number. So these all are called factorization, prime factorization. Okay, so let's write it down. So continued from the previous slide, this is our prime factorization. Write it down. So the prime factorization of 700 is 7 times 2 times 2 times 5 times 5. Okay, so write it down like this one here. That's it. That's the prime factorization. We are done here. Now your book uses some other notations and all that. So I'm just going to take advantage of this slide and introduce you to that notation here. Okay, so for further applications, we met, remember that we have 2 times 2 here and 5 times 5. So we can also use exponents to indicate the repeated primes. Okay, so we can write 2 to the power 2 here, 5 to the power 2 there. They basically mean the same thing here. Okay, nothing, it's just, as I said, it's a notation thing. Okay, now similarly, instead of writing multiplications, okay, conventionally, some of the books use small dots there. Instead of a multiplication, we have a dot there, and we want to start with the smallest factor to the largest factor. Okay, so all convention does not change anything, but we want to stay with the convention. So some problems may use this, some problems may use this. Okay, actually we will use this notation here for further applications. Anyhow, moving on. Now let's look at let's talk about two last but the most important concepts which you will need in this class, and possibly in every class which you will ever take, any math class. Okay, they will come up one way or the other. Okay, and the first one of these is called the greatest common divisor. Okay, greatest common divisor. Now the greatest common divisor, also we write it as GCD, of two whole numbers, is the largest whole number that divides both of them. Okay, now greatest common divisor is also called greatest common factor, okay, or the highest common factor. Okay, different names, so don't be confused. Mostly it's called greatest common divisor, but there are other names as well. If you ever see those, don't get confused. Okay, now the most important use of greatest common divisor is to simplify fractions. Okay, if the fractions are written in higher numbers, you want to reduce it, simplify it. That's where this greatest common divisor comes into play. You will see that in 5.2 and 5.3 coming sections. Now let's talk about how to find greatest common divisor. Okay, so to find greatest common divisor of two or more numbers, okay, we will first write down the prime factorization of each number. Okay, and then we'll identify common factors in both of those factorizations. Okay, we will find the common factors, find factors which form a pair. Okay, you can have repeated pairs. I will explain it with the example here. So we will have both numbers, both factorizations, and then we'll form a pair there. Okay, so if there are more than one common factors, okay, then our greatest common divisor will be the product of all common factors. Okay, so and if there is no common factors, then the greatest common divisor will be just one. Okay, just It's not that important, but you know, um, look at an example here. Suppose we want to find the greatest common divisor of 216 and 234. Okay, so let's find the prime factorization first. Prime factorization of 216 is this and this written out here, starting with 216, 2 and 108, and then 108 is 2 and 54, then 54 is 2 and 27, then 27 is 3 times 9, and then 9 is 3 times 3. Nothing can be further simplified. Similarly, prime factorization of 234 is easy. 2 times 100, 117, 3 times 39, and then 3 times 13. This is the prime factorization of 234. Write them down side by side. Okay, so this is the prime factorization of 216 and 234 there. Now form pairs. Okay, we want to find common in each one of them. Okay, so we have 2 there, 2 there. Okay, we have 3 there, 3 there, 3 there, 3 there. We do not have 13 in this one here. Okay, okay, why I don't have this? Okay, there is a problem. So write down the prime factors here. What we want to do is we want to make pairs here. Okay, so prime factorization of 216 is this, prime factorization of 234 is this. Form pairs. Okay, uh, make as many pairs as you can. So we see that 2 is there, 2 is there, so one pair there. Okay, there is no other 2 here, so we cannot make any other pair. We have 3 there and 3 upstairs, so one pair there, one pair there. Okay, so so our common factors which we can form pairs with are 2, 3 and 3 there, 3 of them. So our greatest common divisor will be the product of these 3 common factors here. So it will be 2 times 3 times 3, so it will be 18. That's our greatest common divisor right there. Okay, next concept is LCM. Now before I get into the details of how to find it, let me explain what does it mean basically. Okay, so there are 3 words if I read it backwards: multiple, common and least. Okay, so 3 words: multiple, common and least. Let me explain each one of them. Okay, so that will make everything crystal clear for you. Now if we talk about multiple of a number is what we get after multiplying it by 1, 2, 3, 4, 5, 6 and so on, so on, so on. Okay, for example, if you want to find multiples of 3, you will take 3 and multiply it by 1, it will give you 3. Multiplied by 2, it will give you 6. Multiplied by 3, it will give you 9. Multiplied by 4, it will give you 12, and so on, so on, so on. It can go on. Similarly, multiples of 5 are 5, 10, 15, 20, 25, 30, 35, so on, so on. Or in other words, you keep adding 5 to itself, keep adding 3 to itself, okay, and keep on going. Okay, so these are called multiples. Okay, multiples of 3, multiples of 5. Now let's talk about common multiples. Okay, so common multiples are that are found in both lists. Okay, so that are found in this and this. So what is common here? I have made it red. So you see that nothing is common, but 15 is common right there. Nothing is common, nothing is common, and then 30 is common, and then list goes on. And maybe there are many more common ones, but I don't know that. I didn't go that far. But in my list here, 15 is common and 30 is common. So write them down here. Now let's talk about the last portion here. Okay, so the least common multiple here is if you have a list of multiples, you have list of common ones, you pick the smallest of the common, which is 15 here. Okay, so you see what it means. Basically we are looking for a multiple and then common multiple and then the smallest of those. Okay, smallest of the common multiples. Let's look at detailed definition. Least common multiple of 2 or more natural numbers is the smallest natural number that is divisible by all the numbers. Okay, now from to find least common multiple or LCM, there are 2 methods which are used. The first method is based upon the prime factorization. Okay, And according to this method, whatever the numbers are given to us, we'll find prime factorization of each number, write it down. Okay, then we select every prime factor that occurs raised to the greatest power to which it occurs. Okay, so we're looking for, the exponent, okay, to the greatest power there, and then form the product of the numbers from step 2. Whatever numbers you just selected, form the product. Okay, and the LCM will be the product of these factors here. Look at example. Suppose you want to find the LCM of 144 and 300 there. Okay, find the factorization of 144 and 300 there. Okay, we have this one for 144, this one for 300. Write them in the exponent form. We talked about it. Okay, now what are you doing? You select every factor here that occurs, raised to the greatest power. Okay, so how many factors we got here? Okay, we have 2. Okay, we have 2, 3 and 5 as factors. So we have 2, this one here, 2, this one here. So which one is the greatest? 2 to the power 4. So we'll pick this one here. Next factor is 3. So we have 3 down to the power 1 and 3 to the power 2. So which one is greatest? This one. We will pick that one. Okay. Similarly, this one, next factor is 5. What is the highest power appears? It is 2. So that's what we will pick there. Okay. So we pick these factors. Okay. Multiply them out, and that will be your LCM. So the LCM for these two numbers, 144 and 300, will be 3600. That's one method of finding LCM. Okay, I hardly use it. I prefer the second method. Okay, second method is based upon the repeated division. That's how I learned it. So I just still use this. Okay, you can use whatever you want. You can use method 1, method 2, or any method you learned, okay, which you are good at. It does not really matter. So now this method, second method, I'll explain it with the same example, okay, which I used for the previous method. Okay, we write these numbers in a certain manner in a row, okay, like this one here. Okay, then you draw these two vertical lines, okay, the perpendicular line to each other. And now this step is important. You start, okay, you pick a number, a prime number, okay, find the smallest prime numbers that will divide evenly into one or preferably both of these numbers. Okay, always try if 2 works or 3 works, the smallest one. Okay, so the smallest prime number is 2. Let me start by 2 here. So I will divide 144 by 2 and 300 by 2. So whatever the answer is, I'll write it there. Okay, so the answer is 72. If you divide 300 by 2, it will be 150, and then we repeat it again. Okay, so again, so we go back to this step here. Find the smallest number that will divide evenly into one or preferably both. So I'm talking about this one here, and I picked 2 there again. Now I will divide 72 by 2, that will give me 36, and I'll divide 150 by 2, that will give me 75. Okay, so this is what I get, and I repeat again. I go back to this one here, find the smallest number that will divide both evenly, okay, or at least one. So this time I'm dividing by 3 there. Okay, so it will give me 12 there and 25 there. Okay, now this time again, repeat this process. Now I cannot divide both of them. Okay, if I want to divide this, I will have to divide it by 5. If I want to divide this, I will have to divide it by 3 or 2. Okay, so I pick 3. So if I divide by 3, this one will be 4 here. Okay, and this one I'll just bring it as it is. Okay, I did not do anything here. And now again, I have a divide by 5, so 4 will go as it is. Okay, and this one here, now this I can divide. Okay, so by 2, and 5 goes as it is. Okay, now all of these are primes. Okay, now to find LCM, what you need to do here is you take all these numbers, okay, all these numbers, okay, and multiply them. Okay, multiply everything to the left, this one here, and remainder, this one here. Okay, and that will give you your LCM. Same thing what we got earlier, 3600. Okay, so these are two methods to find the LCM, or least common multiple. Now I want to finish this lecture with this one application here. This is the applications of least common multiples. Um, it Interesting example. Suppose you are in a movie theater where movies run back to back, okay, and two movie halls, okay. Two different movies start at 4 p.m. One movie is smaller or shorter and runs only for 80 minutes. The second movie is longer and runs for 120 minutes. Okay, it's given to us, or we know that both starts at 4 p.m. Okay, when will the movies begin again at the same time? That's what our goal is here is. Okay, so goal is to find when the movies will begin again at the same time. So basically, in terms of mathematics, we're looking for LCM of 80 and 120. Okay, so LCM will be another number which will be basically minutes. Okay, so after that many minutes, our movies will start again. So let's start by finding the LCM. Okay, so if you want to find the LCM, okay, so start the by finding the prime factors of 80 and 120. Okay, so this is 80 prime factors of that, this is the prime factors of 120. Okay, write them in the exponent form. This is 4 2's, so 2 to the power 4. This is 3 2's, 3 to the power 3 there. Okay, and then we have 2 3 and 5 as factors, and now we'll select each prime factor with the greatest exponent. Okay, so we have 2 to the power 4, 2 to the power 3, so we'll pick this one here, and then we have 5 5, we'll pick 5 and 3. Okay, so you just multiply them. Our LCM comes out to be 240. This is 240 minutes. Okay, if you want to convert them into hours, just divide by 60. Okay, so it will be 4 hours. So after 4 hours, the movies will start again at the same time. Okay, so add, both movies we know previously they started at 4 p.m. So add 4 hours. So at 8 p.m. the movies will start again together. Okay, it was an interesting application. I thought I should put it in there. That's it for today's lecture. Sort of a long lecture, but easy one. Okay, things will get a little bit complicated. So please, try the assigned problems in my math lab. Do the quiz. If you have any questions, please make sure to ask. Okay. Thank you very much. Bye bye.